Hello everyone. In this video I'm going to show you how to create DMVPN and running OSPF over the DMVPN tunnels you have. As you can see on my GNS3 topology here, I have one hop and two spokes, spoke 1 and spoke 2, and they are connected through, let's say, internet. This is just a router simulating the internet, and I have the public IP addresses or NBMA addresses on each link, each WAN link, and on the other hand, behind each router, for example, spoke 1, and spoke 2, I have loopback interfaces which are simulating the LAN IP ranges. Imagine that they are LAN connected behind each router. So our objectives are very simple here. First, we will create DMVPN, and then we will run OSPF running over DMVPN. It means that our loopback interfaces will be able to ping each other and create MGRE tunnel on demand without going through the hop from a spoke to a spoke. So as you know, DMVPN in essence brings us the ability to have full mesh connectivity over an unsecured network without going through the hop, so you can have a spoke to a spoke connection as many as possible. For now, we just demonstrate in this part how to configure the DMVPN. In the second part, we will configure the OSPF, and in the third part, we will configure the IPsec profile and IPsec protection for our tunnel, that we can have encrypted traffic all over the internet for this topology. So just for your information, I have pre-configured this topology. If I want to show you, I have here hub router. Just let's demonstrate where we are. Show IP interface brief, and these are my interfaces. As you can see, this is my public IP address connected to gigabit Ethernet 00, which is my WAN connection, and these are the loopback interfaces which are simulating my LAN. And also on internet router, this router, I have, as you can see, these interfaces. It's not really important because it's going to be transparent for this router. On a spoke 1, I have show IP interface brief. I have one loopback interface and my IP address. This is 808080, right? And I spoke 2, show IP interface brief. This is my WAN connection, and this is my LAN connection. So before we start, we just verify the IP connectivity. I will ping the hop NBMA address 7070.1, and I am successfully pinging from spoke 2 all the way to hop. I'm pinging from spoke 2 to hop, so it means that I have IP connectivity over my internet and WAN connection. So let's kick it off by configuring the hop. So I will go here. Before I start, I have to mention here, as you know, DMVPN configuration is a little bit different than regular IPsec VPN configuration or VTI configuration. So all the configuration have to be performed, almost all of it. When I say all, at least the tunnel interface configuration, all the configuration have to be performed on the interface tunnel, and the only IPsec and routing configuration will happen beyond that scope. So that's kind of easier for us because we will just configure one interface tunnel and we will put all the necessary configuration on that interface tunnel, and we will bring up our simple DMVPN. As I said, for now we just configure the naked DMVPN, so all the traffic will be naked and nothing will be encrypted for now. Okay, let's start from hop. I will just explain quickly each command and the whole configuration. This video assumes that you already know the whole concept and the core concept, the details of what DMVPN is, how it works, what is the purpose. So this video merely only shows the configuration to you guys. Okay, so here we will go to interface tunnel. You can make any number of tunnel, 0 to, as you can see, 214 million something. So we will just put it 0 here. Now the first command I would put is tunnel in mode. As you can see, I have a lot of modes here. I would put tunnel mode GRE multi-point. I'm just telling to my router that this is going to be a MGRE tunnel interface. And then tunnel source gigabit 00. Just let's confirm it. So yes, I'm using these interfaces as my source. Okay, then I will put tunnel key. What is this tunnel key? This is a kind of authentication for the tunnels, not for the NHRP, for the tunnels. It has to match on all the tunnel ends of all the spokes and also hop. So tunnel key, let's say Cisco, it's a C capital. Of course, in production you have to put something more complicated. Sorry, we have to put a number. Tunnel key. And now we will put IP NHRP network ID 1. So what is this IP NHRP network ID? This is the ID of your NHRP domain. This ID is local, is significantly is locally significant. So it means that it can change for on your spoke 1, spoke 2, but we don't change it because of the sake of the consistency over our configuration. So I just put it IP NHRP network ID 1, IP NHRP authentication. This is going to be the authentication key for authenticating our NHRP domain. Here I would put, for example, Cisco. Then IP NHRP multicast, map multicast dynamic. It just enables, it tells our this command actually is a very key and important command. It tells our tunnel interface that multicast, dynamic multicast traffic and NHRP traffic is allowed to this router, is allowed from and to this router over this tunnel interface. Okay, IP NHRP map multicast dynamic, and then I would put IP MTU 1400. And why? Because, as you know, the default MTU value is 1500 bytes, so we just put 1400 just to leave out some room for a GRE encapsulation to not exceed the 1500. So we will put also IP TCP adjust and MSS 1630. So one point that I want to mention here, that on IPMTU you can actually also mention, you can also IP MTU, sorry, IPTC, IP what was the command? Just a second. There was a command that you can put and it can dynamically detect the MTU over the path, but we don't use it now because it shows. I just don't remember it. Okay, no problem, it's not that much important. So we usually don't recommend that, because I usually don't recommend that, because in production it has proved itself that it doesn't really work, and it confuses the MTU setting over the path, along the path and your router. So MTU value won't be really consistent for your hub and spoke. So it's better you just hardcore the MTU value. The last piece is IP address of the tunnel. So as you can see here, I will have put DMVPN range as 192.168.0. This is 24 actually. 24 and hop. So 0. I would put 70 for hop. 255, 250, and that's it. Let's check. Show run interface tunnel 0. I have my IP address, MTU, IP NHRP authentication, IP NHRP map multicast dynamic, IP NHRP network ID, source. Yeah, we are good to go on the hop. Let's go to spoke 1. Here we are on spoke 1. Let's say like this. Okay, conf interface tunnel, we can put any number we want, 1. So the configuration on the spokes are a little bit different than hop. You have to add more data and more configuration lines and commands, because you have to hardcore the NBMA address and NHS address of the hub. You have to declare it for the spoke where to go to establish the tunnel. So let's do it together. The first thing we would put is tunnel mode GRE multipoint, tunnel source gigabit 01, tunnel key 123, IP NHRP network ID 1, or you can put it as I said, whatever you want. It's just the ID of your NHRP domain. IP NHRP authentication Cisco, it has to match with the authentication key you put on the hub. IP NHRP map multicast dynamic just gives the permission to your tunnel interface that hey, you can use multicast dynamic traffic. IP NHRP map multicast. Now here, as you can see, you can put the NBMA address of the hub. So by this command, you would tell to your tunnel interface that you can send your multicast traffic to this NBMA address actually, which is 70.70.70.1. Then IP NHRP NHS, we will introduce the NHS to our router, spoke 1. So we will tell them that who is the NHS server, which is our hub, and this is the very delicate point and important point here, that you have to use the private IP address of the tunnel, not the NBMA address. So we will put 192.168.0.70 right IP NHRP map. So on this command we are mapping. So here at this command we told the tunnel interface that hey, if you want to send NHRP request, you have to send to this NHS server, and you can find this NHS server on this IP address. Now, how on earth this tunnel interface knows how to interpret this IP address. So here we will map this IP address, the NHS IP address, to the NBMA, to the relevant, to the corresponding NBMA address. So we'll put IP NHRP map, again the tunnel interface, and here the NBMA address. So 7071, right? Okay, IP MTU 1400, IP TCP adjust MSS 1360. As you know, MSS is 40 byte less than MTU. IP address 192.168.0.80. 255.5.5.0, and that's it. Let's take a look. Show run interface tunnel 1. Okay, we have the IP address, we have the MTU, NHRP authentication, map multicast, then it's multicast, and NHRP multicast is mapped to the NBMA address. Then we have defined the NHS, and here we have mapped it to the NBMA address, network ID. Yeah, it looks good. So let's see what we have here. Show IP NHRP. As you can see here, I have one NHRP entry on my NHRP table, and it says that this IP address, which is my DMVPN, my MGRE tunnel IP address, there is a entry for this, and the NBMA address, the corresponding NBMA address is this one, and it never expires because it's static. So if I ping my, let's say, first NBMA address, it's successful. If I ping the other side of the tunnel, and it's also successful. So if I do show DMVPN, I can see here that I have one entry. The peer NBMA address is 7070.1, which is the hub, the tunnel interface, and how much is it up. Great. Let's go to SPOOK 2 and configure SPOOK 2. Conf interface tunnel. I will just not explain anymore, as you know. I will just go through quickly. Tunnel interface, let's say 2, tunnel mode, GRE multi-point, tunnel source, gigabit 0, 2, tunnel key 1 to 3, IP NHRP network ID 1, IP NHRP authentication, Cisco, IP NHRP map, multicast dynamic, IP NHRP map, multicast 707071. One important note here: if you forget to enter these commands, you wouldn't be able to run any IGP or routing protocol over your tunnels, because, as you know, all the IGPs like OSPF or EIGRP, they run multicast traffic. They generate multicast, and they are listening on multicast traffic. So that's not going to work over your tunnel. So these are the key commands for your DMVPN configuration. Okay, IP NHRP NHS, it's 192.168.0.70. IP NHRP map, again this IP and the corresponding yes, and IP MTU 1400, IP TCP adjust MSS 360 IP address 192.168.0.90 on the thread, and that's it. Show IP interface brief. Okay, show IP NHRP. As you can see, I have one static, so let's ping spoke 1, which is 80. Perfect. So if I do show IP NHRP here, as you can see, I have two more entries. This one was static because I entered it myself. This is the NBMA address of the hub. This one is dynamic, so it dynamically resolved the NBMA address by the help of hub. So the hub, we sent basically what happened behind the scene was we quickly sent an NHRP request to NHS server, which is the hub, and it sent me back 80.80.80.1, which is the NBMA address of spoke 1, and I can now reach the other side of the tunnel here. And this one is also my router unique local. It means that the flag is router unique local. It means that this is my own NBMA address. We are pretty good. So if I do show DMVPN, yes, I have two entries, one for the hub and one for the spoke 1. Let's check one more, the hub. Show DMVPN. Yes, I have a spoke 1, a spoke 2, VPN HRP. Yes. Okay. I have both here. I have both IP addresses. This is spoke 1 and spoke 2. This is perfect. Everything is going fine. Just to be on the safe side, I will ping from a spoke 1, a spoke 2, ping 70 dot, no, sorry, ping 90.1, and it is successful. I just pinged this side of the tunnel and my traffic went directly. So what it means exactly is that just as I started the ping, a tunnel on demand came up between these two. So something like this, a tunnel in demand, something like this came up between a spoke 1 and a spoke 2, and they could talk to each other. So on the next step, we will run OSPF here on our DMVPN backbone in a way that our loopback interfaces can talk to each other sorry, through the DMVPN. I hope it was informative for you, and we will switch to part 2 soon. Thank you.